Example 2. The first census in the U.S. was in 1790. It showed a resident population of 3.93 million people. From 1790 through 1860, the population of the U.S. grew by about 3% each year. What is the initial value? What is the growth factor? In order to determine what the initial value of this function is going to be, you have to determine what your variable is going to be. In this case, since the first census is in 1790, we can let our variable, say t, be the number of years since 1790. So the initial value is going to be the value of the function when t is 0. What is the value of the function when t, our variable, is 0? That's the population of the U.S. in 1790, which is 3.93 million. In this case, I've decided that n is the population of the United States in millions. What do you multiply a population by to get the population after 3% growth? After a population has grown by 3%, it is 103% of its original value. So the number you multiply by is 103%. So the growth factor, the number you multiply the population in 1 year by to get the population in the next year, is 103%, which is equal to 1.03. So the growth factor is 1.03. Note, it is not 3%. 3% is how much it grows. 103% is how big the population is compared to what it was a year ago. Let's write an exponential function for the population of the U.S. as a function of the number of years since 1790. We have n of t is the function. The initial value is 3.93, since n is in millions, times the growth factor, which is 1.03, to the power of the variable, which is t.